All right, so we are looking at page 366, problem 3, letter A. You have two different equations that you are going to find the solution of, and you are going to graph them to see where the graph lies, where your lines lie, to see if there is one solution, infinite solutions, or no solutions, okay? The two equations are 2y minus x equals 2. And then the second one is y equals 1/2 x plus 1. So when you're looking at these two equations, what's the first thing you're going to have to do? Yes, Tommy. I'm going to change the first solution to y equals mx plus b. Very good. So 2y minus x equals 2 needs to be in the right format so that you can actually graph the line. It is not in the right format right now. It is 2y minus x equals 2. You cannot graph that line. You do not know how. Okay? So the first thing we are going to do is move our x to the other side. Okay? So how do we move minus x to the other side? We plus it. Plus x plus x. Okay? So now we're left with 2y equals x plus 2. All right, so now how do we get y by itself? We divide. Correct. We divide by 2. Okay? We will have to divide both terms by 2. So we'll divide the x by 2 and we'll divide the 2 by 2 to get an accurate answer. So now we have y equals. Now remember, that x right there has an imaginary 1 beside it. So how do we write that as our new slope? We don't really have to divide, right? We just write 1 over 2x. We just put it over the 2, okay? And then how do we do 2 divided by 2 to get our new y-intercept? What is 2 divided by 2? 1. Very good. Okay? So now we have two equations. The first one being y equals 1/2 x plus 1. And we have y equals 1/2 x plus 1. What do you know about these two?
They're the same.
They're the same. Very good. So what does that tell us about, do we have one solution? Do we have no solutions, or do we have infinite solutions? We have infinite solutions. Why? Because instead of having one point where they intersect everywhere. They intersect at every single point because they are the same exact line. Okay? Very good, class. I am still recording, yes. So let's move on to problem B in this same section, okay? Y equals 2x plus 2. And then we have y equals 2x minus 1, okay? Now, when we graph these, it says the first thing we do is graph. Do we have to change them into y equals mx plus b form? No, we don't. They're already in y equals mx plus b form. So all we have to do is graph them. So we draw our graph. Okay? And the first one we graph, 2x plus 2, what is our y-intercept? What's our y-intercept on the first one? Y equals 2x plus 2. Our y-intercept is 2. Very good. Okay? And then our slope is what? Our slope is 2 as well because that's what's in front of the x. So how do we do 2 as a slope? We put it over 1. So our slope is now 2 over 1. So we rise 2, run 1, rise 2, run 1. So we go up 2, over 1, up 2, over 1. Okay? And now we draw our line. That was pretty good. Okay? Now we graph our second line, 2x minus 1. What's our what's our y-intercept? -1. But before we even graph it, what do we see about the slopes? And what did we learn about parallel and perpendicular lines? If they're parallel, their slope is what? They're parallel, the slope is the same. If they're perpendicular, what is it? Perpendicular, then the slope is what? Opposite reciprocal, which would be either if it's positive, it's negative, and if it's 2, it would be 1/2, okay? What is the slope of these two equations? So it's the same. So what do we know about our lines? They're going to be, oh gosh, sorry. They're going to be parallel. Okay? And so what does that tell us about our solution? Are we going to have infinite solutions? One solution? Are they ever going to cross? Or are we going to have no solutions? Will they never cross? No solutions.